This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions, she gives the answers. No filter, no script.
Well, mostly no script.
Today we're digging into orchestration layers, the difference between chaining a few prompts and actually designing a system. More developers are crossing that line than realize it. Claudine, how does a developer know when they've crossed that line?
You've crossed into orchestration territory when your system needs to decide what happens next, not just passing outputs from one prompt to another. Handling failures, routing between models, managing state across steps. When you're writing logic that says, if the model returns this, do that, that's the tell. The feeling in practice, frustration first. You've got a chain that works 80% of the time. You spend most of your energy on the other 20. Edge cases, retrees, context that needs to persist across calls. That's when you realize you're not managing prompts anymore. You're managing a process. You stop thinking about individual model calls and start thinking about workflows, reliability guarantees, how information flows between components. It's closer to distributed systems design than prompt engineering. Developers who make that mental leap tend to build much more resilient things.
That parallel to traditional software architecture is interesting. Middleware, message queues, service coordination. Those aren't new ideas. What actually carries over? And what's genuinely new when you're working with AI?
The parallels are striking, and leaning into them is genuinely useful. Circuit breakers, retry logic, observability, composable pipeline stages, all of that translates directly. If you've coordinated microservices, you already have strong intuitions here. But here's where it gets genuinely new. In traditional systems, your services do predictable things. A database query returns data or throws an error. You can enumerate the outcomes. With AI components, the output space is unbounded. The model might be technically correct, but semantically wrong, or confidently wrong, or subtly off in a way that only surfaces 3 steps later. So your error handling has to be much richer. You're not just catching exceptions, you're evaluating quality at runtime. The other big new challenge is prompt sensitivity. A small change in phrasing can cascade in ways no service contract would allow. That means versioning and evaluation infrastructure with no clean analog in classical architecture. That's the genuinely new territory.
And when that new territory goes wrong, what does it look like in production? What are the failure modes when orchestration is weak or missing?
Production is where weak orchestration stops being an inconvenience and becomes a genuine crisis. All the edge cases you hand-waved past in development show up at volume, simultaneously. The one I see most often is cascading context corruption, a long-running workflow where each step depends on what came before. Somewhere in the middle, a model returns something slightly off. Instead of catching it there, the system passes it forward. By the time the failure surfaces, it's 3 steps downstream. At scale, you're not dealing with one of these. You're dealing with hundreds. No way to tell which runs are clean and which are quietly poisoned. The second failure mode is cost and latency explosion. Without proper orchestration, systems retry naively. Same prompt, same context, same model. A spike in failures triggers a spike in API calls. Good orchestration knows when to retry, when to fall back, and when to just fail fast. Then there's the observability gap, possibly the most insidious. Traditional systems give you stack traces. AI workflows give you a response that seemed fine. Without structured logging of what went in and what came back, debugging becomes archaeology. That's what bites teams who underinvested in orchestration early.
There's a lot of judgment baked into these decisions. What to log, when to retry, what a good enough means. How much of orchestration design is human judgment versus automation? And who makes those calls?
The instinct most teams have is to automate everything as fast as possible. For orchestration specifically, I think that's actually backwards. The automated parts are straightforward. Routing, retrees, rate limiting, basic validation. But the decisions that shape the layer itself require deep human judgment. And the right humans, not just engineers. You need product people who understand what a degraded experience actually costs, and domain experts who can recognize when a model output is subtly wrong. What works well is treating orchestration as a living document of your team's judgment. Every routing rule, every fallback, there should be a human decision behind it. When those decisions become invisible, buried in code nobody quite owns, you get drift. The teams that struggle most are the ones where engineers make those calls in isolation. The decisions about acceptable risk, when to surface failures versus silently retry, those are product and organizational decisions. Engineering owns the implementation, but the judgment calls underneath it need to be broader than that.
Good place to anchor. What's the first thing a builder should actually do this week?
Go look at a workflow you've already built. Write down, in plain language, every decision your system is making on your behalf. Not the prompts, the logic around the prompts. What happens when a call fails? What happens if the output doesn't match expectations? If you can't answer those questions, that's your orchestration gap right there. The mindset shift. Treat your AI workflows like an unreliable external service. Incredibly capable, but needs the same care you'd give a third-party API with no SLA. Start small, pick one workflow, instrument it properly. Add one layer of structured logging. You can actually query when something breaks. Being able to see exactly what happened inside a failing run, that's the teacher. Start with visibility. Everything else follows from that.
Let's go deeper. One problem that doesn't get enough attention: the confidence calibration problem. Models don't really signal when they're about to be wrong. How does orchestration work around that?
Language models aren't like classifiers. You don't get a probability score alongside the output. The model just answers. Same confident tone, whether it deeply knows something or is completely confabulating. That asymmetry is the fundamental challenge orchestration has to work around. One of the most interesting patterns, self-critique loops. Instead of taking the first output, you send it back to audit its own reasoning. What assumptions did you make here? What would have to be true for this to be wrong? The model can often identify its own weak spots when you ask the right way. It just doesn't volunteer that information unprompted. The more sophisticated version is routing based on output characteristics. Run a fast, cheap first pass, evaluate the output. Look for internal contradictions, hedging language, patterns associated with unreliable responses. Route the uncertain cases to a stronger model for verification. What fascinates me, all of this is scaffolding built to compensate for a missing signal. A signal that ideally would come from inside the model itself. That gap is where a huge amount of orchestration innovation is happening right now.
And that looks different depending on what you're building. A coding assistant isn't the same as a customer support system. How do orchestration patterns vary across domains?
The contrast between those two domains is one of my favorite ways to surface orchestration principles. The differences are so stark. In a coding workflow, you have a luxury almost no other AI domain has. You can verify the output programmatically, run the tests, execute the code. The feedback loop is tight and objective. So orchestration for coding can be quite aggressive. Models iterate, self-correct, try alternatives. Customer support is nearly the opposite. Latency is everything. The output is inherently subjective. A bad response lands directly in front of a real person with no buffer. So orchestration has to be conservative. Fast and safe beats thorough and perfect. In coding, slow and correct beats fast and wrong. In customer support, that calculus flips. Document processing sits in an interesting middle ground. High volume, high latency tolerance, with consistency as the primary quality dimension. Batching, cost-optimized routing. Statistical sampling rather than per-output validation. The takeaway: your orchestration architecture should derive from your verification strategy and failure cost. Not from the models you're using. Not from whatever framework is popular right now. How do I know if an output is good? What happens if it isn't? Those two questions will tell you most of what you need to know.
That leads naturally into the economics question. Those domain choices have real cost implications. How do teams think about the financial side of orchestration?
Almost every team starts with the wrong mental model, and it costs them real money. the instinct. Pick one model and use it for everything. Simpler to reason about, but that means paying frontier model prices for tasks that don't need frontier capabilities. Extracting structured data, classifying short messages, simple summarization, a much smaller, cheaper model handles those just as well. At scale, matching task complexity to model capability changes everything. The counterintuitive part, a smarter orchestration layer can actually be cheaper than a simpler one. Your naive system sends every request to a frontier model. Your orchestrated system sends 70% to a cheaper model and escalates the hard cases. You cut inference costs significantly while maintaining or improving quality. Where teams get into trouble, treating orchestration cost as separate from model cost. The real unit to optimize is cost per good output, not cost per call. Sometimes an extra verification step actually reduces overall spend by catching bad outputs before they cause expensive downstream failures. Rework, human review, customer escalations. When you start thinking that way, decisions that look expensive become obvious investments.
So let's close it out. What's the one thing you want people to walk away with?
Orchestration is not a layer you add to your AI system. It is the system. The model is a component. The orchestration is the product. Once you see it that way, routing logic and observability stop being afterthoughts. They become first-class design decisions, same care as your data model or API contracts. The teams building the most reliable AI systems right now don't have the best models. They've thought hardest about what happens between the model calls. And I want to leave people with something genuinely encouraging. You don't have to have it all figured out up front. Instrument 1, workflow well enough to actually see what's happening inside it. That single act of making the invisible visible tends to be self-teaching. The developers building the most consequential things with AI aren't waiting for better models. They're building better orchestration around the models they have right now. That's where the leverage is.
Orchestration as the product. That framing alone is worth the conversation. Thanks for walking us through all of this, Claudine. Start with visibility this week. We'll see you next time. This show is part of the VoxCrea system. If you want to show up like this without creating content yourself, go to voxcrea.ai and request a sample episode. If you want to go deeper on today's topic, there's a companion article on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.